Hello and welcome to our live launch of an element of creativity. We're really excited to be finally sharing this resource, which is a long time in the making, and introducing both some of the teachers and also some of the researchers who are involved in making it. My name is Lewis Hu. I am director and founder of the Science Ceilidh, and really proud to have worked with colleagues at the University of Edinburgh as well as Bilston Primary to develop this interdisciplinary creative resource for primary learners exploring chemistry from P1 all the way to P7. I would love to hear who is listening at the moment. You might be coming in from our Facebook or our Twitter account. So if you're listening, tell us where you're from, say hello, we can see your comments. And as we introduce our speakers, as we go a little bit later, and any questions that you might have, we will be able to see and be able to put to them as we go along. Just to give a bit of a flavor of what the resource is, just to give a sense, the resource is a focus on the chemistry curriculum in the primary school activity, kind of primary school classes, I should say, and years. I think one of the motivations, and we'll talk a bit more about this with Gemma as we come along, was really identifying that chemistry looks like lots of different things, and it's not just all explosions, though of course explosions are great. And so we developed a program with the University of Edinburgh at the time, the chemistry department, to think about how could we explore chemistry and show the creativity behind it, the fact that it's applied in lots of different things. And so the motivation for the resource is really trying to diversify and show different facets of the chemistry behind everyday life, and particularly looking at it not at the high school level, but at the primary years, and starting to challenge maybe some of those stereotypes early on. Alongside that, what transpired through working with the researchers is actually finding lots of research links about how it connects to sustainability and how chemistry can help us battle climate change by making batteries, for example, more efficient, fridges more sustainable, as you'll hear a little bit later, recycling the gold from phones, for example. And because we're the Science Ceilidh, we really wanted to make sure that we also embedded expressive arts, creativity, embodied movement, and play throughout these activities as well. And finally, we also wanted to share the different facets of what chemistry researchers might look like, how they ended up in chemistry, and the other creative things that they do. So it's really exciting for us to be able to finally launch this. This was a long time coming. It was linked with a international year of the periodic table. And then, of course, the pandemic had other plans. But we did manage to deliver these activities with the researchers at Bilston Primary, who are one of our partners developing this, before we then took a little bit of time to refine, reflect, and then develop the resource, which we will be sharing very soon. Before I introduce the resource a bit further, I'm going to obviously thank our funders, the Royal Society of Chemistry, who supported this work, and definitely proactively thanking Bilston Primary and all the teachers there and all the learners who were involved in the development of this, as well as our researchers too. Very, very quickly, let me just show you a kind of quick summary of what you might expect with the resource. Today is half of our launch. So today we're going to be talking about two of the kind of lessons. We have building blocks, which looks at the basics of what everything is made up of, and keeping cool, which is understanding how fridges work and looking at energy. And then tomorrow we'll be introducing three other activities and lesson plans: warming up, gold phone soup, and molecular machines. And each one of these are designed to focus on a different element from the periodic table, and also build on each other. And so actually it should be a complete curriculum. The first building blocks can then be differentiated, even though we've designed it to work with P1s, to work with older years as well. And they build off each other. So warming up, for example, we'll look at different states of matter and energy, and then that understanding can then build on to understanding keeping cool, for example, which looks at how we can then use this to make materials more efficient, and so on and so forth. So that hopefully just gives you a bit of a bird's eye view of the resource. Of course, you'll want to see it and download it, and then we'll talk a little bit more about how that process will work and what materials are available. But before I keep muttering on, I'm going to actually introduce one of the teachers that helped us develop this resource, Gemma. Hello, Gemma.
Hello, hello, hello.
How are you doing?
Very well, thank you. Yeah, really good. It's really been nice to chat again after COVID stopped our fun.
Absolutely, and it's so good. And I remember this really fondly, but we were looking for a primary school partner, and I remember giving a talk at Dynamic Earth. I think it was a CPD a couple of years ago at around interdisciplinary learning, and then we mentioned this project and the fact that we were looking for a partner. And I remember both you and your colleague Phoebe were so keen. You came out to find us, and we're like, we need to talk.
Yeah, absolutely. Our school at the time was a small school. We've grown a lot since that point in time. And we were relatively new, so we were kind of not really on the map. Nobody kind of knew who we were, and it just seemed like a really exciting thing to be involved with. And it happened at a time where my development of STEM within school was kind of at a very early stage, and it seemed really fortuitous that there was this kind of springboard into kind of getting it all going and getting the kids excited about it as well. So yeah, it was all the planets aligned.
Exactly. And was there any particular motivation around, you mentioned kind of the beginning of your journey into STEM as well, the interdisciplinary elements of what we were trying to propose?
Yeah, I mean, I kind of took on the lead for STEM within Bilston, and was trying to kind of fumble my way through developing at the core skills that children could apply across lots of different contexts. And yeah, trying to work my way through kind of developing a program and a scheme and something that could be accessed by all the children, but had a clear development and a clear line of development. And so when the science Ceilidh kind of came on our radar, there was a dual element of the creativity and the fact that it was linking to dance and expressive arts and children moving. And it's tried and tested. If children move and do, then they learn so much better. Alongside all that science development and getting down to the nitty gritty. Although I enjoy science myself and I love to teach it, chemistry probably wasn't my speciality. And I think probably as educators, we can be a little bit tentative about dipping our toe into the periodic table at primary level. And so having this as an opportunity to start exploring that, building our confidence, getting the children excited, and just having that awareness was something that myself and my colleague Phoebe were really excited about. Her with her expressive arts head on, and me with my STEM head on. It just felt like it would really, really work.
Awesome. And we'll hopefully chat to Phoebe tomorrow as well, for the second half of our launch. Okay, so then tell us a little bit about the process when we were delivering. What was that like from your end when we were working, bringing the researchers in, people like Claire, who we'll meet a little bit later, delivering the workshops? What was the feedback back from the young people and from the teachers?
It was really interesting right at the beginning. One of the very first things Lewis had the kids do was to draw a picture of a scientist, and that threw up so many misconceptions about the white lab coats and the goggles and mainly male. And it was really brilliant to just unpick that right from the get-go and say, well, actually science looks like this in our world and scientists look like this in our world, and just introduce the children to the different facets of it. So the feedback from that was really, really powerful. And actually a lot of the children will still hark back to that. If a kid says, only boys can be scientists. No, they can't. So yeah, it's nice to know that they've got that kind of embedded straight away. Once we got going with the workshops, there was definitely a buzz and enthusiasm in the school. That anytime anybody was coming in, any part of the team was coming in, it was kind of, you could tell the kids were excited. They were keen to do a little bit more. And there was kind of no holds barred with questions as well. They could ask anything they wanted to know. They literally had an expert in the school who could answer the questions that we as practitioners didn't quite know at the time. So the feedback from the learners there was amazing. They were able to share their learning with younger children, with us, with their parents. And then among the teachers, it was just kind of, oh, this is actually not as tricky as we kind of initially thought it would be, to have a group of children all working through this kind of learning. as Lewis said, it doesn't all need to be explosions and test tubes. You know, it can be literally as simple as having a camera on a fridge and looking at how that works. So yeah, it was really good for us to kind of shelf our fears and just go with what actually is a really effective way of teaching these elements of science.
Definitely. And I think you picked up there some of the kind of other motivations that implied, but, you know, we try and take that as a kind of science capital approach where we, you know, we know that a lot of the stereotypes about science and who scientists form, what counts as science, forms really early and primary. And this is, again, one of the reasons there's lots of resources out there for secondary schools, but actually a lot of those preconceptions begin at primary and are very resilient, actually. And so, you know, that's one of the reasons why we want to tackle that at this level with teachers like yourself, and to try and kind of broaden what counts. And I think, you know, we try to understand and what people thought of chemistry and what does that look like. And I think there's lots of misconceptions in the evaluation around, you know, things like, oh, it's all about drugs and chemists from a pharmacy perspective. And as you say, there's quite a big gendered element of it as well. And as you say, you know, the movement, the pedagogical elements of trying to make it really active and bringing in a researcher was really key to us, and hopefully something that we can even continue as we share these resources moving forward. I mean, hopefully there are some educators watching either live or catching up. Do you have any tips or words of encouragement for those educators who are listening, who might be interested in this?
I mean, so when we first kind of signed on to work with the Science Ceilidh, we kind of went away and had a look at the resources as they were. And straight away, you know, we were all kicking ourselves of, why did we not use this before? The information is all there. The resources you will need are all there. The glossary of the terms that are used is all there. It's just go with it, have fun with it. If you have fun with it and the learners see you having fun with it, that's going to excite them. Just like anything that we do, if we're enjoying ourselves, the kids are too. And I think it's just, if there's something you're not sure of, do the typical teacher thing and have a look at it the night before. But yeah, I reckon that once you get going, just go with it, and actually let the kids lead it, because what they come up with was really surprising in a brilliant way.
Awesome. Thanks so much, Gemma. And definitely, I think we try to account for that flexibility as well. You know, we want teachers are the experts. They know their young people the best, and young people can lead this type of work. And so, you know, I think we're quite optimistic about how much you can fit within a lesson. So I think we try to be a little bit more realistic about that, but we've designed the resource to be a bit more modular, you know, and to bring in different ideas that you might have as well. So hopefully it's a springboard, as you say, moving forward. Awesome. Well, thanks so much, Gemma. If you have any questions for Gemma, just from a practitioner perspective as a teacher, please do fire them into the comments. We will be able to see them, or any reflections indeed. And we'll bring Gemma back on towards the end to answer any questions as well. So thanks so much, Gemma.
Thank you.
And that's a brilliant transition to bring in someone from our team just to talk about the practicalities of what is actually going to be available. We have Alexia, who helps develop our resources from Science Ceilidh. Hi, Alexia.
Hi, thank you, Lewis, and thank you everyone for joining. So I'm part of the Science Ceilidh team, and I was involved in the design and development of this resource. So we've spoken a bit about the content, but I'll tell you a bit more about the practical side of it. So everyone who's joined today will be sent a link to the Google folder, and all of the resources will be on there. So the main resource that Lewis shared a couple of slides from, and then there's also accompanying slides for each chapter. And the resource will be downloadable and can be printed. I think that's everything for now. And it will also eventually become freely available to everyone on our website. It's just first access for those that have joined today.
Thanks so much, Alexia, and thanks so much for your work putting all this together. You didn't get a chance to see it in person, did you? But some of them.
A couple of the chapters, yes, but not all of them. So it's nice that it's going to go out into the world now and more people will be using it.
Exactly. Yeah, we spent quite a lot of time reflecting with the Bilston Primary School teachers after we developed it with the researchers, and then you did the hard work of putting all that together. So thank you so much, Alexia. And absolutely, so if you're watching and you've registered with us by the Eventbrite, i.e. we have your email in some form, we will be sending you a copy of the resource very, very shortly, hopefully by next week is the plan. And that is a Google document with all the PowerPoints and all the videos and everything like that. Alongside that, we will be asking you if you want us to keep in touch with you. And the reason for that is that we're hopefully going to be revising. We want to hear your feedback about the resource. It is a living resource. We want to hear practitioners, what works, what doesn't work, what other ideas. One idea that we're hopefully developing is creating maybe a Google Meet space. This is fresh off the press with Gemma, and thinking about actually, keep that kind of continual space where we can maybe bring some of the chemists and to answer any questions as you go along if you have them, and actually just and potentially planning some CLPL sessions come September as well. So if you want to keep in touch with us and Science Kaylee generally, all our resources, our interdisciplinary resources, are always free, and we do have a mailing list as well. So please do leave your email when you register to then download the toolkit. But if you're watching this and you've registered on the Eventbrite, don't worry, you will get an email very shortly. If you are watching this and you haven't, you've just stumbled across it on our Facebook and Twitter, lucky you, then I would recommend maybe signing up for the Eventbrite tomorrow, just so we have your email, or sending us a wee message and then we can send it that way. Awesome, thanks so much, Alexia. We're going to now introduce two of our researchers. So we're going to introduce two of our resources. The first one is building blocks, which was developed with Dr. Fabio Nudelman. And this is the kind of beginning, so kind of P1 and upwards, really thinking of the very basics of how can we explore what is everything made of and how chemistry is absolutely involved in that space. So for this resource, Fabio is actually giving a lecture at the moment, so he couldn't join us live, but we pre-recorded an interview with him. So I'm going to put that video on. It's about just over 7 minutes, just talking through the resource, showing some of the different aspects of it and some of the activities, and linking that to Fabio's research as well. So enjoy. I will see you afterwards when we'll be joined by the next researcher, Claire, live.
I'm come originally from Brazil, where I did a first degree in biomedical sciences, and I've been living in Edinburgh. It's going to be probably 8.5 years by now. And my main research is, I'm mostly interested in trying to understand the building blocks of life and how life is enabled by chemistry. So that's mostly what my research is about. Besides research, I have other hobbies. I like reading, I like listening to music, I like playing games, and I like to practice Aikido, which is a type of Japanese martial arts.
Awesome. It keeps you busy.
It does.
Amazing. Okay, well, yeah, tell us a little bit about your research then. So you're a chemist, you study chemistry, and you study building blocks. What is your research?
Yeah, so topic of my research is an area that is called biomineralization. So it's a name that sounds really complicated, but actually what we're trying to understand is how organisms make all kinds of different materials like bone, teeth, and shells, which are a combination of proteins and minerals like calcium carbonate or calcium phosphate. And it is the use of these minerals that give all these materials the properties that they have. So that's what makes, for example, our bones very strong and able to support the weight of our body, and our teeth hard enough so that we can chew food and eat, and shells that are hard because they have to protect the animal inside. And there are many different examples in nature of all kinds of different materials that combine some kind of mineral to make something different that is going to be useful for the animal.
So what I'm hearing is, everything's made of building blocks, and in this case, bone, shell, teeth, even chalk are all made from the same building block, which is calcium. And that's the calcium we might drink in our milk, but actually because of the way it's made up of, it will kind of give it the different properties. That's why shells can be quite hard, bones are really hard, and teeth even harder. Is that right?
Yeah, that's right. I mean, what makes this material different from one another is how these building blocks are organized. So as you said, they're all made of calcium. So in a way, they're all very similar, especially if you think about chalk and shells, which are all made of calcium carbonate. But of course, chalk is very soft, and that's why we can use it to draw on a wall or on a blackboard. But obviously, you cannot do that with a piece of shell, or you're going to accomplish is a horrible noise. And that is just because of the way that calcium is combined in there, and how those small building blocks or arranged into a larger material.
Brilliant. Well, how does that influence and inspire our resource? What do we actually end up doing in the activities that we have in building blocks?
So we talked about building blocks in the activity, and of course we focus on calcium as the main building blocks, and we did a number of different things to kind of illustrate the concept. So the first thing that we did was to get the children to build things with Lego, and it's a very nice example because it's just with Lego bricks that you can build I don't know, an infinite number of structures that are completely different. And of course, they can be can build a building, can build a bridge, whatever you like. And of course, some of them are going to stand better than others, depending on how you build. So that illustrates very well how we can use the same building blocks to make different structures that serve for different things. So that was the first one. We did an activity that was revolving around looking at those materials in the microscope. And that was very nice also to see how these building blocks are arranged and how they actually look like, and how different they look like under a microscope than they look like to the naked eye. And that can give a sense, again, of how these different building blocks are organized. We did an activity about dancing, so we tried to represent that through dance and movement, which was really interesting to see. And the final activity was to get the children to draw a superhero kind of material that they would like, and what kind of property or what kind of building block they wanted it to have.
Exactly, because that's the whole point of your work, is how we can learn from different materials like teeth, like bones, and actually make other things harder, make them less likely to break because of the chemistry behind it.
Yes, exactly. I mean, you can think that if you understand how what our teeth are made of, and how our bodies make the teeth in the first place, we can try to think about how we can repair cavities in the teeth in a way that's not just by filling them with resin, which is what the dentist does at the moment. Or if you think about bones, how we can help the body to heal a fracture better than it already does. Or even in cases where the body cannot heal a fracture, then you have to end up putting an implant.
Exactly, yeah. And a fracture being a broken part of the bone.
Yes. Yes.
Brilliant. And then maybe, I mean, the dance, I think for you was maybe a new one in terms of using Cayley dance to explore how the different shapes, you can represent the different shapes of calcium, for example, for the different bones. We did have a screenshot taken from the resource, actually. Hopefully this will work. In terms of just showing the teeth, the bones, the shell, the chalk, what it looks like under a microscope, and then also some examples of how you could represent that using Lego to begin with, and then through a dance as well. But yeah, I guess, is there anything about this activity that you want to tell us a little bit more about?
I think that the activity using Lego was really nice and really interesting, is exactly because it shows how we can use the same building blocks to build completely different things. So that is one thing that I particularly liked about it, and I think that illustrates very well the concept. And you see here in those in the screenshot that you're showing, if you look at chalk, and you can think of Lego bricks that are just disorganized, that they're not even fit into each other. And that, in a way, that's exactly what chalk is. I mean, a structure, I mean, a material that is made of small particles or very small bits and pieces that are just very loosely held together. And then just next to it, we have a piece of shell, which is exactly the same material, but we see that it's made of building blocks that are kind of like a brick wall. And that makes it, of course, very hard. And we see that the Lego represents that very nicely. How I have those building blocks basically stacked on top of each other and basically glued to each other in a way that the shell doesn't break.
Brilliant. Thanks so much. And that is the challenge to you, perhaps watching or facilitate, is who doesn't love to Lego, and what could we
Yeah.
build, and what might that suggest about it being strong or light or easy to crumble. Amazing. Thank you so much, Fabio. And it was a little while ago since we delivered these workshops in schools, but yeah, what was your overall impression working with the P1s?
I think it was fun. It was a new experience for me. I think it was really interesting. I think the children really enjoyed it. So that was nice. I liked it.
Amazing. Well, if you've got any questions for Fabio about his research, about anything linked to the resource, please do get in touch with us and we can put you in touch and answer any questions you might have, or the students might have as well. But Fabio, thank you so much for your time. And yeah, I look forward to seeing what everyone gets up to with your resource.
Yeah, thank you. Thank you, Lewis.
I think I'm unmuted. So I was just making a joke about wearing almost the same shirt, which is somewhat embarrassing, but there you go. Thank you so much, Fabio, for joining us. And if you do have any questions about that resource in particular, please do let us know. There are lots of activities in there looking at the microscope, and the resources complement that as well. And again, one of my favorite moments is certainly looking at things like using the do-si-do and not touching and going around each other to represent the chalk, and the versus, for example, being really tight knit, perhaps in a different molecular structure for calcium. So our next resource, and we're going to introduce live, follows this session, I guess. It is with Dr. Claire Hobday with her resource Keeping Cool. And this one is designed with P3s and 4s in mind, and builds off Warming Up, which is the second resource that is introduced tomorrow with Hannah. And this one in particular builds on kind of covering the states of matter and energy, but then focusing on how we can use this to make our fridges more efficient at keeping things cool and environmentally safe. So we have Claire with us over here. Hello, Claire.
Hi, sorry, I didn't prepare myself to unmute myself either. The running the theme. Hi, Liz, it's nice to see you again. Hello to everyone.
Lovely to have you here. First, Claire, why don't you tell us a bit who you are and how did you get into chemistry in the first place?
Yeah, thanks so much. So yes, I'm Claire. I'm a chemistry scientist at the University of Edinburgh, and my research has kind of got an environmental focus. So I'm trying to make materials that are better for us and also for the planet that we live in. So I got into chemistry because I just had a really enthusiastic chemistry teacher at school that I had the whole way through high school and every single year. So there's a bit of continuity there. He's called Dr. Crawley. And he was really enthusiastic and passionate about science in general and chemistry specifically. And he kind of passed that passion on to me. And he had a really good, fun teaching style. And yeah, I went to Strathclyde to do a degree in chemistry. And then I went to Edinburgh to do my PhD. And I'm still there. So yeah, so outside of work, I'm also a human being. So scientists are, normal people. We have hobbies and stuff, and we are creative people. I think people forget that sometimes that scientists are also creative. So yeah, so I'm into cooking, which I suppose is just like chemistry. And I like cycling because it's a way of kind of keeping fit, but also getting places. On a day like today, you've got to take your chances. Sun's shining, but it was raining about an hour ago. And yeah, I'm also really into music, which is why I was quite interested in working with Science Ceilidh, because I've recently gotten into more kind of traditional Scottish music and play my guitar.
Awesome. One day we'll have you in our band, Claire. This is part of the recruitment. Brilliant. And then can you tell us maybe a bit more about your research then? Again, this is the research that inspired the activity.
Yeah. So I'm trying to make materials that when you apply pressure to them, they change their structures. Kind of like how Fabio was talking about, if you take similar building blocks and you arrange them in a different way, you get a material with different properties. So what we do is we take a material that's in a certain state and it's solid, and then when we apply pressure to it, it'll like change its state. So you can think of something like carbon has different structures with different things. So if you apply pressure to your pencil lead and left it for thousands of years, and applied really, really high pressures, you would eventually make a diamond. So we're trying to do things like that, but on smaller pressure scales and shorter time scales. And so we're trying to basically use the fact that when you change from one solid to another, you can have an exchange of heat, or cool, I suppose, the opposite of heat. And we can kind of use this to make fridges or any kind of air conditioning or anything that needs a temperature that's constant more environmentally friendly. So to do this, I kind of do a mixture of computational modeling and like actual physical experiments. And the upside of using computers is you can do things that you wouldn't normally do in the lab, and you can do it thousands and thousands of times. And it means it's also kind of more environmentally friendly in that way, because you're not kind of wasting materials.
That's awesome. I remember actually my favorite experiment when we started converting this into something suitable for P3s and 4s was actually the fact that if you get an elastic band, and this is what you taught me, and then we could just demonstrate by stretching it really quickly, that change of, well, it's not a full strain state, but it becomes a little bit looser, and that actually generates heat. And we kind of, I think there's a video that we've included in the resource looking at that in an infrared camera. So you can kind of, it'd be great. It's great to get the learners to do it, but it's the same principle, right?
Yeah, exactly. So like the molecules are arranged in a particular way, and then when you like stretch your elastic band, they'll like change shape, and then they're going between different structures, and then you're physically doing that with like some rubber. And actually people are trying to commercialize that at the moment. So like there's been a study on like using like rubber as a way of cooling down or heating things up in a sort of sustainable manner.
So there's the elastic bands that those massive balls that you always find in a school. There's always at least one. The massive balls that's maybe generating some really interesting energy. Awesome. So then how about, how does this translate into the activities? So Keeping Cool has loads of different ways of exploring this with P3s and 4s. I can share a sneaky peek at the resource, if that's useful, Claire.
Yeah, that'd be great, thanks. Yeah, so the resource is called Keeping Cool, and it focuses on the element fluorine. And the reason that we've chosen fluorine for this is because that's what refrigerants are mainly composed of at the moment. So they're molecules called hydrofluorocarbons. And so these hydrofluorocarbons are liquids, and they go between liquids and gases. So this builds on Hannah's resource that you'll see tomorrow about, what's it called, heating up. And this is called Keeping Cool. So we're basically exploring the states of matter. So we're going between liquids and gases when we do refrigeration in your fridge that you've got in your kitchen. And then I'm also talking about going between different solids, so between two states of solids. So yeah, the activities, there's 5 of them. I think one of my favorite ones was activity 2. It's at the bottom of this page, where we got the kids to think about how you can generate cool or take heat away from something. And one of the ways to do that was to kind of play around with evaporation of a liquid into a gas. So we got them to get some hand sanitizer. So when we did this activity, it was it February 2020? It was like just before everything changed. And so now everyone's really familiar with hand sanitizer, and we have loads of it. So it'll be a great activity to do, and the kids will be really familiar with it. So we got them to kind of get hand sanitizer and put it on their hands and to kind of experience that feeling cold, and then to kind of change that with just some water and to see how it still makes it cold, but it's not as good as evaporating off. And yeah, the kids like getting their hands dirty, or well, clean, I suppose. And then if you're
Awesome.
able to switch slides.
Definitely. But just before you move, I actually remember that moment really well, because when we were buying the hand sanitizers for your activity, Claire, it was actually really hard to find it, because it was just when people started bulk buying it. That was the moment it was starting to change, so we ended up buying some very fancy hand sanitizer for the P3s. We're moving swiftly on.
So then we kind of talk about before fridges. And fridges are a fairly like novel invention in terms of like how long we've been on this planet and kind of thinking about how people kept things warm beforehand. So a little bit of kind of historical science. So you see here, there's a really kind of cool picture, which is like a fresco from the like Egyptian times, and you can see that there's a servant who's fanning these jars that are full of water, and it's that evaporative cooling that's happening again, where he's fanning the jars to sort of encourage the water to evaporate into the atmosphere, and it will cool the pharaoh who's sitting on his chair with his staff. And then we also talk about the ice trade, which is kind of, up until we had fridges, the main way that people got things cool. So they took giant blocks of ice from cold places and transported them all around the world. And so there's, we showed a scene from Frozen, which I think captivated the children, where you can see all the big guys at the start and they sing a song in Frozen. And that captivated them, I think, kind of seeing how we used to do it. And then, yeah, the big activity is activity 4, which is how do fridges work, which I think is quite complicated, but hopefully we've simplified it down quite a lot, that it should be easy to explain, and also that the kids should enjoy themselves, because it's revolves around a dance that we made to kind of get them to think about the steps.
Thanks, definitely. And what I love about this, and we'll expand on that a little bit more, because I think it's good to pick actually how do fridges work. But I think that was a really, the historical context of how we kept things cool, and again, it comes back to the motivation behind this resource, is in that there is chemistry in our kitchens that we don't think about, and how fridges work and the magic of that. And it's not magic; it's science, it's chemistry, and so really, really good to be able to highlight that. Okay, so this is the $1 million question, and how does a fridge work?
Yeah. So hopefully, you've got a nice little slide. So this is the amazing artwork done by Alexia as well, to make it nice and visual. So there's only, I suppose, 4 steps. The 5th step here just kind of is back into step 1 again. So if I can start you guys in the condenser coils, so where the sort of red line is, that's the back of your fridge. And you'll notice when you're at the back of your fridge, it's kind of got lots of little wires that go like this, and that's where the refrigerant molecule is. That's where our hydrofluorocarbons are. And they're in a liquid state, and then they pass through into step 2. They pass through this expansion valve, which basically drops the pressure in the system, provides opportunity for the molecules to, instead of being in their liquid form, to expand out into the space and become a gas. And so when they do this, we're kind of basically doing evaporative cooling. So we're taking the heat away from wherever we're going to apply this gas to. And that's basically kind of inside your fridge is where these coils end up going, behind the PVC. And so they take the heat away from your the food, the apples or the carrots, or the watermelon.
It's a very healthy fridge.
It is. It's a great fridge. So then we take all the heat away, and it'll go all the way down, and then it'll get into the compressor. So this is then in step 4. So we're now into the compressor, and so all this, you're taking the heat away, so our liquid or gas is now quite hot, and it goes into the compressor and gets converted back into a liquid again. And so the reason that those coils are at the back of your fridge when it gets converted back into a liquid is like the liquid's quite hot still. You can kind of give the chance for the heat to be exchanged, just like with the air that's in your fridge. So if you're ever feeling cold, you can just kind of turn your fridge around and you'll feel the warmth from it. Wouldn't recommend that though. And then when we just start the cycle back again, so our refrigerant's then back in our condenser coils, and it goes back through the expansion valve. So the dance that we made around this was getting the pupils to kind of form like a circle, and there would be people who were pretending to be the expansion valve at one end, where they would pull away from the circle, and then A couple of kids pretending to be the compressor, which they loved because it meant they got to squish whoever went through them. And then the circle would just go around. They would kind of run, so they would get faster when they were a gas, and they would slow down when they were a liquid. And yeah, it was quite, I think they quite enjoyed it.
Definitely. We definitely used the big hall for that one.
Yeah.
Running about as quickly as possible. And I think really trying to, this is a complicated process, even for me to get my head around, even as a non-chemist. And so trying to understand, I guess, those changes in state and how that helps, just again, like I think the example you're talking about, things evaporating and making things colder using hand sanitizer, for example, is very similar to that kind of step 2 of what the fridge is doing and removing some of that heat. So really trying to press that ahead. And we've got some videos that we've included where me and Claire sat with an infrared camera and filmed a fridge like you've never seen it before at the back, for example. But then also trying to think about that from a embodied perspective, using the dance and really getting young people to think about the change of states and how that would take heat away or and help cool things as we go along. I think this is our video of the fridge in real time heating up once we left the door open, for example, compared to here, for example. And red being the warmer part of it. And so this video is included within the resource, so you can use this as a way of being able to see it, hopefully in a way that's a little bit safer and a bit more visual as well for learners. Brilliant. And anything to add, Claire, from your side?
No, I don't think so. I think just that I really enjoyed myself. It's good to see the resources kind of come to life with the learners and to kind of understand what you need to be able to explain a bit better. I think that is one of the downsides of chemistry or science in general, is people are quite scared of it, and then scientists themselves are probably sometimes not the best at explaining it. So yeah, it's been really useful to work with the kids and with Bilston Primary to reach a level of understanding where yeah, we're all getting something out of it, and it's really enjoyable.
Awesome. Thanks so much, Claire. Well, if you're listening, actually, even if you're catching this up and you have any questions, please do let us know now. This is your chance to ask Claire, to ask Gemma, or we can pass things on to Fabio. Any questions that you might have about the resource or some of the chemistry behind some of the science. Obviously, you haven't seen the full resource yet, and we will be sending that out, and there will be other opportunities moving forward too. But I will bring Gemma back on just as we go along. Hey, Gemma.
I got the sun behind me. I've got like a celestial glow.
I know. It's quite glorious.
Not my usual look. It's okay.
Exactly. This is great. So whilst waiting, just in case there are any questions, I thought maybe it would be good to maybe come back to yourself, Gemma, and actually, the school's has grown. You've got new P1s and P2s, and so what are your upcoming plans? And are you hoping to do this again?
Yeah, I've got for the last kind of few weeks of term, we're usually at the kind of point of winding down and tying up a lot of loose ends and things. But yeah, the last couple of weeks we're going to have a little mini science Kaylee in P1 too. So yeah, we're going to go back and have a look at the building blocks, which I'm really quite excited about, especially with my current group of learners who are big into their technologies. And if I say that we're going to get to play with Lego as learning, they're going to absolutely combust. And then moving forward, I think the really good thing about this resource is because it's kind of wrapped up neatly in a bow. And so you could actually just pick it up and run with it. So with new learners coming in, new class, come August, yeah, definitely going to kind of hit the ground running with a lot of the science Kaylee elements that are being developed, also because we're part of it, so it just makes it extra special from Bilston's point of view. But yeah, just give the learners that really early opportunity for teamwork and communication. Again, just at the very, very core, all the skills that we need for all of our learning, not just in science. So yeah, that's our kind of that's my goal anyway. And again, because we've got all these new staff and new children, just making them aware of this amazing set of resources that are literally at our fingertips to use. So yeah, I'll keep flying the Science Ceilidh flag.
You can join the band as well, Gemma.
Thanks.
Awesome. But no, that sounds really good. And I think that's really what we were excited by. We wanted to make sure these resources felt like comprehensive and that teachers can deliver them. And actually, not just teachers, actually, we'd be really interested to see youth workers or people in CLD, community learning and development might be able to adapt these resources too, and still hear from, you know, the voice of the researchers through that to get that element.
Yeah.
Awesome. And then maybe Claire, from you, what was your favorite part of delivering the activities? Do you have a particular moment, or I know it was a few years ago, but
yeah, it was a wee while ago. No, I think it was probably the first activity we did, which I think was the hand sanitizer experiment, and it was just like seeing their faces, and kind of when you do something that's a little bit more practical and they're just kind of really into it. And yeah, like it's been a long time since I was in a primary school, and it's just, you forget like how much excitement they get from activities and things. It's really nice.
Awesome. And they love smelling hand sanitizer. It's
I don't know if you would say that now, Lewis, to be honest.
That's very true. Now it's oh God, do we have to? I'm sure.
And we didn't give them the fancy stuff, I'm afraid.
It was like essential oils and everything, because everything else is
oh wow, where was this from? Yeah. Why did we not get any?
Awesome. Well, thank you so much, both Claire and Gemma, for joining us, and Fabio for joining us through the recording. Thank you, if you're watching, for joining this session. We're going to be back tomorrow, or for our second half, we'll introduce the other 3 resources, and very similarly, just give you kind of a bird's eye picture of what the resource is, and a chance to actually speak about and understand the chemistry behind this. And this video is recorded, so it is a resource if you are, once you've read through the resource, it might also make sense to come back to this and hear from Claire and Fabio directly as well. So hopefully gives you a bit of that context whilst you're preparing for these classes. We have our warming up gold phone soup and molecular machines activity tomorrow. And as I said, if you want access to the resource and you're watching this, if you've signed up on the Eventbrite already, you will be sent a link. If you've not, do register for tomorrow, or send us a message, and then we'll make sure that you're also included in that email list, and we will send you both the recording and the resource ready to be used. So thank you so much, Claire, Gemma, Alexia, for joining us beforehand, and cheery bye.
Thanks so much.
Bye.